This sort of question, it's worth spending a little bit of time thinking what to focus on first. And in fact, we've got two 3-digit numbers and they're adding together to give a 4-digit number. We know that JMC and JMO are going to both be less than 1,000 because they're 3 digits. Therefore, SUMS or sums must be less than 2,000. Because it's got 4 digits, S must therefore equal 1. And that's a good little starting point to have. So let me write it out again. JMC plus JMO is going to equal 1 UM1. Right, next line then. Now I can say that C plus O, this is an O rather than a 0, is either going to equal 1 or C plus O is going to equal 11. To get that 1 here, it can't equal 21. It can't equal 21 when we add them because they're both less than or equal to 9. Now, if C plus O is equal to 1, then because they have to be different digits, well, we'd have to have 0 and 1, but we've already used 1, so we can reject this one here. And in fact, it must be that C plus O is equal to 11. I don't know how it's going to equal 11 yet, whether it's 6 and 5 or 8 and 3. We'll come back to that, but it's a good little thing, it's a good little fact to have. Because I've got C plus O is equal to 11, I can now carry 1 here. So when I look at the column to the left, we've got 2m plus 1 must equal m, or 2m plus 1 must equal m plus 10. Can't equal 20 again because m is less than or equal to 9. Now this clearly gives no solutions. I'd end up with a negative, I think. M would equal minus 1. So we can reject that one, which means that m must equal 9. All right, brilliant. Let's rewrite it then. J9C plus J9O can equal 1 U9 1. And remember, we're carrying 1 here. And then because we've gone with m plus 10 here, we're also going to be carrying 1 here. Now onto this final column on the to the left again. It must be that 2j plus 1 is equal to u, but we know we're carrying 1 to the next column, so it must be u plus 10, which means that u is going to equal 2j minus 9. And I think we're now ready to work out all the solutions. Remember, we've got C and O, but okay, let's focus on this one to start with, U and J. So I'm going to think about what J is, which will help me find U, and then I can find a C and O pair to go with it. Remember, we know that S is 1 and M is 9 throughout. So let's say that J is equal, I can't have equal to 1, but could it equals, no, it can't equal 0. Okay, actually it's going to have to be 5 or more. So if it's 5, then I would get u as 1, so I can reject that. If it's 6, then I'll get u as 3. Okay, this is okay. We'll worry about C and O in it. No, let me get C and O now, actually. So I need pairs that add to 11. In fact, I am going to write down S and M for each of these, just so I know that I'm not going to use them twice. So 6 and 3. Okay, to add to 11, I can't have 9 and 2 because I've already used 9. I can't have 8 and 3 because I've already used 3. 4 and 7 would work. Or I could swap it around and do 7 and 4. So we managed to get 2 solutions. If I then go for 5 and 6, that's not going to work because I've already used J as 6. Brilliant. Let's increase again. So J is 7. So now I'd get U as 5. Okay, that seems to work. I need C and O to add to 11. Let's try again. 2 and 9, no. 3 and 8 would work. Or 8 and 3. And this was 5 and 7. If we went with no 4 and 7 isn't going to work, and nor 6 and 5. So we've got those other two. And then we could try 8. So then you would be 7. 3 and 8 doesn't work, 4 and 7 doesn't work, but 6 and 5 this time does. It's a really nice problem with all these different configurations. Okay, so both of these are okay, and 1 and 9 here. We can't let j equal 9 because we've already used it, so those are our solutions, and there are 6 in total. Well done on this question. Actually, one thing just to add at the end is that here they are. Okay, I've written down all the different values, but here are the actual sums. Nice.